Wait a minute. Oh, hello. All right, welcome back to Monty's Python Show. In today's video, we're going to be working on a code-along tutorial exercise where I'm going to be showing you how to use the data that we brought in from the Tesla CSV file, and we're going to create some interesting time series analysis using a line chart and combining that with a bar chart. We're going to plot the historical stock price for Tesla and historical trading volume over time. And we're going to add some decorations to the chart and make it look interesting and to help it tell an interesting story. We're going to be picking up with the code that you would have completed in this exercise in your Canvas, which is Unit 5, getting data from .csv into Pandas. So make sure that you have downloaded the data, which can be found on the Canvas page here. And make sure that you've gone through this tutorial so you have the basic file that we're going to use right here. So we're going to build off of this file. So you want to have this file in a directory and a project directory. You should name that project something, that directory something descriptive. And also make sure that your data file is in the same directory, so when we import it, we won't have to search for it in a different directory. Okay, so let's go ahead and get started. So this is the code that you would have written in the lesson from Canvas. And the first thing I want to do here, I'm going to clear out my console, is let's run this code and see what it does and make sure that it works without error. Okay, so over my console you can see I have the first 5 lines from the data frame printed out with column headings and some data. So the code seems to be working good. So before you move on, make sure that your code up to this point is correct. Pause the video, go back and correct anything that you need to. Okay, so the first thing we're going to do in this analysis is I'm going to rename my data frame something more generic here instead of Tesla. I'm just going to change it to lowercase df. And I'm going to get rid of this line here where we're printing out the header. Okay, so now our data frame is just going to be called df. This is a common use or common thing in Pandas and Python programming. You'll see a lot of programmers use lowercase df to refer to their data frames. So df is a good generic name. Okay, so for our analysis in this video, the first thing I want to do is I want to get some information from the data frame. In order to do that, one of the things that will make it easier for us to work with our data frame and get information from it is we want to reset and change the index. Right now, if you look in the console, you'll see that the index of this data frame is actually integers. So 0, 1, 2, 3, 4, that's the index. And what I want to do is I want to go ahead and change the index to be the date column. And when you're doing time series analysis and you're referring to information in the database, or in the data frame, you might want to refer to a particular date to get some data, and it's much easier if the date is your index. So what I'm going to do is up here in my load data function, I'm going to add a line right after where we create the data frame. So between the data frame equals and the returned data frame, we're going to add the following line, df.set_index. So that will change and set the index to whatever we specify as the argument here, and I want to set it to date. And then we also want to use the in-place argument, in-place equals true. Okay, so now if I run this code, let's run it, and let's go down here and let's just inspect our data frame here. Now you can see that the date is the index field of our data frame. And we could use, I could print out df.head, and that prints out a little bit nicer. Okay, so you see now the date is our index. And that's going to make it a lot easier for us to do some analysis down below. So let's go down here. I'm going to go to line 19 and put a comment in. Let's get some information from the data frame. Okay, so the first piece of information I want to get is the starting date of the analysis. I want to know when the start date of my time series is. So I'm going to create a variable SD, short for start date. And I'm going to set it equal to the value of the date, the very first date. Now, since the date is our index, we can access it like this, df.index, and then pass the index integer 0. Okay, so if I run that code and go down here in the console and look at what SD is, I can see that SD is a timestamp, which is 2014 February 11th without a time. So in this particular data frame, the date came in, Pandas made that a timestamp, which is related to a datetime object. So it has a lot of the same sort of attributes as a datetime object. So for example, SD.year 2014 and get SD.month. So you can get similar attributes as you can with a datetime object. And we can manipulate timestamp objects mathematically like we can with datetime objects. So this is all good. Okay, so that's our start date. Let's get the last date in the analysis, the end date, ED, so we know both the beginning and the ending of our data. And that's going to be df.index, and we just pass -1. So you can see the indexing of the data frame in the index works very similarly to indexing strings, lists, and tuples. 0 is the first element and -1 is the last element. And then let's calculate the total number of days that are in the series. So, and let's call that T. T equals the ending date minus the start date dot days. Okay, so that ending date minus the start date is going to create a time delta object. And then from the time delta object, we can access the days attribute. So that's what .days is doing. So this will get the number of days between those two dates. And then I'm just going to divide that by 365. So I'll run that, and let's see what T is. T is exactly 10. So that means we have a 10-year period looking at the number of days from the beginning to the end. Okay, so we've got some basic information from the data frame that we can now use in some calculations on the data. So we're going to do some calculations and calculate some summary statistics from the data in the data frame. So put a little note here, calculate calculate the summary statistics. And the first thing we want to calculate is what is the total rate of return from investing in Tesla stock over that time period. And so we're going to create a variable, tot return, and we are going to set it equal to. Now, if you don't know, the total rate of return from investing in a stock over any time period is just simply the ending adjusted stock price divided by the beginning stock price minus 1. So how do we get the last adjusted close divided by the first adjusted close? Well, we're going to reference the data frame series in there. So we want the data frame ADJ space close. You can see that's the name of that field that we want. And then we want to get the last value. Now, unlike when we grabbed the indexes, we could just pass the index directly in square brackets after index. Here with the series, the columns, we need to use the .iloc, the .iloc method. I got two dots. iloc. That's index locator. I guess that's short for. And so the last one is going to be at -1. So we're looking in the adjusted close column, but we're indexing it using the .iloc. So we're indexing it using the index locator. Okay. And we're going to divide by the same thing, but we want the first stock price in the data frame. So df, again, we're using the adjusted close, and .iloc at index 0 minus 1. So that's your formula for total return for owning Tesla stock from if you bought it at the very beginning stock price, adjusted closing price, and then you held it until the end. Let's go ahead and run that, and let's see what that number is. So I'm going to type in tot return in my console, and there you go. That's a huge rate of return. It's actually, that's not 13.76% because this actually returns a value that is in decimal form. So you have to move the decimal place 2 to the right. So this is actually 1,376.7%. That's the total return from investing in Tesla over that 10-year period. Okay, so that's our total return. And now let's calculate the annual return from that. So that total return, but it's over the course of 10 years. And so we can annualize that total return, and here's how you do it. We're going to create a new variable called ANReturn. And we're going to set this equal to 1 plus the total return that we just calculated. And now we're going to raise that to the power. So we're going star star to the 1 divided by t. Oops, that's a 7. T, end parenthesis, and now subtract 1 from that. Okay, so we're basically taking 1 plus the total return and raising it to the 1/10th power, because t is 10. And that is how you calculate an annualized return from a total return. So you don't divide the return by 10 because returns compound. And maybe in a later video we'll demonstrate how compounding works. But for now, just believe me that this is how you calculate the annualized return from the total return. Okay, so let's run the code and let's see what that is. And return. And return is about 30, just inside of 31%. So if you invested in Tesla back 10 years ago and held on to it, you've made about 31% each year on average. Okay, so that's your mean annual return. Okay, so we also want to see how volatile is Tesla stock. In other words, how much does it move up and down on average? Does it move up and down a lot, or is it pretty steady? And to measure that, we're going to use the standard deviations. We're going to calculate the standard deviation of the daily returns, and then we're going to annualize that. So we're going to express the volatility of Tesla's returns as the annualized standard deviation taken from the daily percent changes. Okay, that's a big mouthful, but here's how we calculate that. So we're going to create a new variable called vol. Okay, we can calculate that using the .std method that is built into Pandas. But first we need to calculate the percent changes. So we don't take the standard deviation of the stock price. You take the standard deviation of the percent change in the stock price, or the log change in stock price. But most commonly people use the percent return, percent change in the daily stock price. And so here's how we're going to do that. We need 3 opening parentheses. Okay. Now we're going to grab the adjusted close column, df. Okay. That's the adjusted close column. Okay. And inside, so we're going to go just outside that first set of parentheses right there. And we're going to use the percent change method from Pandas. So dot pct underscore change. So that will calculate the percent change from one period to the next. Okay. Then just outside of that, so in the outside of that next parenthesis, we're going to drop NAs, and I'll tell you why in just a second. So we're going to do dot drop NA, beginning and ending parenthesis. And then outside of that final parenthesis, we're going to calculate the standard deviation as dot std. Okay, so this that seems like quite a bit there, but what we've done is we've taken the adjusted close, the daily adjusted closing stock price, and we've calculated the percent change. And the percent change just represents 1 day's adjusted close value divided by the prior day minus 1. And so the very first data point in our data frame, you can't calculate a percent change from it because there is no value that comes before it. So what ends up happening is in that first row, you have an NA for that percent change. So that is why we put the drop NA before we calculate the standard deviation. Okay, now that represents a daily standard deviation of stock price returns. And we need to annualize that. And if you're a statistics buff or you know anything about it, if you've taken AP Stats, you know that the variance of a time series expands with time. So variance expands with time. And the standard deviation is the square root of variance. Therefore, standard deviation expands with the square root of time. Since this is daily return, we need to turn it into an annual return by multiplying it by the square root of time. And time means how many increments of time there are in a full year. So there are about 252 trading days on average in a typical calendar year. So remember that stocks don't trade on the weekends. They only trade during the week, and they don't trade on federal holidays. So we're going to multiply this times 252 in parentheses, and now we're raising that to the power of 0.5. Hopefully that makes some sense to you. If it doesn't now, when you take college statistics, it'll make a lot more sense. Okay, so we've got some interesting summary statistics we can use. Now what we want to do is let's go ahead and create a chart now. All right, so we're going to create a chart of historical price, and it's commonplace like in stock trading and investments to look at the volume and the price together. Okay, so the volume represents the number of shares that are traded each day. All right, so I'm gonna change our style to a dark background, so I think it looks cool. So first thing I want to do, let's change the style to dark mode. And you do that like this. We need to also import our package up top. So up top here, let's go ahead and import matplotlib.pyplot as PLT. Okay. Now down here, we can go ahead and use our PLT alias like this, plt.style.use, and we're going to use the style dark_background. Since I'm in dark mode in my editor, let's go ahead and use dark mode for the chart. Okay. So in this case, we're going to have multiple axes because I'm going to have both price information and volume, and they have very different scales. So I'm actually going to use both y-axes. So I need to do this a little differently than a single axis chart. And here's how you do that in Matplotlib. I'm going to create a figure and an axis object right now. So let's say create figure and axis objects. And it's going to go like this: fig and ax1 equal plt.subplots. Okay. All right. So that won't do anything yet, but you'll see how it will all come together. Now let's go ahead and let's plot stock price on let's see, as a line on the primary axis. Okay. And let's set our color to orange. All right. And so here's what we're going to do. We're going to use this ax1 object. So ax1 dot set x label, and the x label in our chart is going to be date. Okay, because that's what's going to be on the x-axis. We're gonna plot prices over time. So it's a time series chart. Okay, then ax1. Let's set our y label as, say, adjusted stock price. Okay, and I want to set the color of that to match the color that we're going to use also for the plot, so that it matches. So I'm going to set color equals color. Okay, so the color is the keyword argument for the set y label method, and the other color, the equals color, refers to our variable, which is orange. Okay, let's go ahead now and make our plot. So ax1 dot plot, and we want our x-axis to be the dates, which is our index of our data frame. So df dot index, and then our y is going to be the adjusted close. Okay, and then again, we're going to make our color equal to our color. Color equals color, which is orange. Okay, And let's also make the axis tick, so the color of the actual axis ticks in the line itself. Let's make that orange as well. So ax1 dot tick underscore params axis equals y, and we're going to set label color equals color. Okay. Let's just going to go ahead and go down here and make a few lines, and let's do plt.show. And let's just see what happens when we run our code, make sure we're not getting any errors. Okay, so there you go. You see that we've got a plot of the Tesla stock price starting at 2014, and then you can see it starts to really move around 2020, around COVID. And you notice that the line is orange, and also our label and our tick values on our y-axis are orange as well. So that makes it easier to identify that, because we're going to add some data to this chart, and by color coding it, it's going to make it easier. It's almost like a legend for us in our chart. Okay, so now how do we add the secondary data, the secondary axis data, which is going to be our volume data? All right, so let's make a little note here. Plot volume as bar on the secondary axis. So we're going to make volume be a bar chart. So we're going to overlay two different charts in one. Okay. And one thing we're going to do is we're going to sort of copy we're going to marry the secondary axis to the primary axis by having the same x-axis. So we don't want two separate plots. We want to put both of them on one plot. And so what we need to do is we need to connect them via the x-axis. And so we're going to create this ax2 object, and it's going to be equal to ax1 dot twin x. Okay, so we're creating basically we're twinning or joining, if you will, the x-axis of our two y-axes, so they'll both appear on the same plot. Okay, and we're going to set our color equal to green for this. And so let's go ahead and build out our ax2 object, which is going to be our secondary axis. So ax2 dot set underscore y label is going to be volume, and the color of that is going to be green. So it's going to be color equals color again, because we've redefined color. All right. So that's our Y label. And you notice we don't have to set the X label, because it's going to use the same X label from AX1 because of this part right here where we basically joined the two using the same X axis. Okay. So now let's go ahead and chart our bar graph. So it's AX2. So we're telling the object we're plotting this on axis 2. It's a bar chart. And our x-axis again is df.index. Those are the dates. The data that we're going to plot, the height of the bars, is df volume. Okay. Color is going to be green, so color equals color. And then set the alpha, which will set the width of the bars to 0.5. And you can play around with that and see how that changes, but let's start it off at 0.5. Okay. And then the last thing we're going to do is set the tick parameters, and we want our secondary axis to have the same color as the data, so we want it to be green. So we're going to set ax2 dot tick underscore params axis equals y, and label color equals color. All right, so let's go ahead and run that code and see what happens. Okay, so now you can see that we have two charts in one. We've got the original data, the stock price, and now we also have volume plotted as a bar chart down here. And it looks like maybe our volume and our data frame, we might be missing some data, or it may be You notice here where it says this 1E8. This is basically telling you that it's actually using scientific, exponential notation with 8 digits. This 8 is really 8 times 10 to the 8th power. So this is like 80 million. I think I'm doing my math right. So it could be a scaling issue too. That's why maybe these were just low volume periods here, and that's why it's not showing up. Okay, so pretty cool. We need a couple other things though. Let's create a title for our chart. We need a good title here. So let's create a formatted title. So I'm just going to put a note here. Create a formatted title. And so this is going to be plt.title. And I'm going to do this formatted message here. So F, and let's say historical stock price and volume for, and we have ticker field, so we'll just hard code this for Tesla, and then let's put a date range in there for, let's do it on that's going to be a big title, so let's do it on a new line. So I'm going to do the new line, so \n, so it'll print down on the next line. And we want to print out the start date, SD, and we need to format that. Let's format it SD. So let's use the stirf time method. Remember from the date time module, the stirf time is how you format strings and print the data out as a formatted string. And let's just have it so that it prints out the month. So percent capital M / capital Y, let's say. So that'll just print out the month and the year. Okay. And then this needs to be in a parentheses, not a curly brace. Okay. And then I'll do a little dash, and then just move this over a little bit. And then let's do the end time. So ed.stirf time, and that will be formatted again as month / year, and close that off. And let's see, I think we need one ending parenthesis. And just check what I got here. Unterminated string literal. Let's see. Oh, I got to end my string right there. Okay. And f string singled. Okay. I have got an extra right here. I need the starting curly brace. Let's keep unterminated string. Where is it? Unterminated. Oh, right here. It's a long line. There we go. Okay. So that's what that code looks like right there. Let's go ahead and run it and see if that works. F5. Okay, that worked. So it didn't print out the month very well, did it? Ah, okay. This should be a lowercase m. Lowercase m. Let's try that. Oops. Because I didn't type an M in. Try it again. There we go. Okay. Finally got that working. So we've got a little says historical stock price and volume for Tesla from February 2014 to February 2024. All right, cool. All right, so there's one more thing I want to add. Let's add some data about the return, maybe in the volatility that we calculated. Let's put it actually in the chart. So you can actually tie things to data inside of your chart. You can print formatted strings or data from your data frame. You have lots of options. So I want to add the text to my axis 1. So I'm going to go axis 1 dot text. And here's what we're going to do. First you tell it the X and the Y values that you want. So the X value that I want it to be all the way to the left of the chart. So that's at df.index 0. So that will print it all the way over here on the left side on this border. And then you tell it what Y value you want that text to print at in your chart. And the Y value, we're going to do it up toward the top. So we want to be close to the maximum, the highest level, but not quite at the top. So let's do this. It's going to be df adjusted close is going to be what we're going to use. And then I'm going to use the max method dot max. And so that's going to be the Y level where we print it. So we'll print that, and then we can adjust it. And then you tell it what string you want it to print. So let's print out a formatted string that says capital CAGR. That stands for CAGR, or compound annual growth rate. That's just a common way of saying the annualized return. Equals, and then we'll have the _return variable. And I'm going to format that for 2 decimal places as a %. Like that. Okay. End curly brace. And then I'm going to do a bar. And we're going to have the volatility. Let's make this a little bigger. Equals curly brace. And that's going to be our vol variable. And again, I'm going to format that as 2 decimals %. End curly brace. Okay, it looks pretty good. So if you've got that set up, let's go ahead and run it and see what it does. There it goes. So it printed that little message right there at the top of the screen, and you can see that that left side is lined up with the first data points on our chart. And maybe it's a little high. We could move that down a little bit. So watch this. So down here in the ax1.text, the Y argument it's the highest possible value of adjusted close. Let's move that down a little bit. We can move it down by multiplying it by some number less than 1. I'm going to multiply it times 0.9 and run it again. That should move that down a little bit. There you go. So now it's kind of more in the chart, a little easier to see. Maybe that's too low. I'm going to move it back up a little bit. I'm going to change it to 0.95 and run that again. There, that looks pretty good. So we've got a pretty good looking chart of historical stock price for Tesla and the volume. We've got it color coded so you can clearly see that the price is this axis, the volume is this axis. You don't even need to have a legend. We've got a 2-line title for our chart, and we've got text inside of the chart that we tied to specific X and Y values. We figured out how to do use a secondary axis in our plot and plot 2 different types of plots, but a line and one, which is just what Matplotlib just calls it, a plot. And we also have a bar chart, which Matplotlib refers to as a bar. So overall, pretty cool. So hopefully this helps you understand how to get data into a data frame from a CSV file, then how to use that data frame to make a visualization of the data, and how to access individual pieces of data inside the data frame to do analysis, exploratory data analysis and summary statistics, and then make some pretty cool charts. All right. So until next time, keep the crumbs out your beard and Python.